A quadratic function is a function that can be written in the standard form y equals ax squared plus bx plus c. It does have a restriction, and that is that a cannot be 0. And it makes sense because if a was 0, then we would have 0 times x squared, 0, and you will end up with a linear function, not a quadratic function. There is another form to write a quadratic function, and that is the vertex form. And it is y equals a parenthesis x minus h squared plus k. The parent function of a quadratic function is y equals x squared, and the graph is called a parabola, and it has a U-shaped form. We're going to start by graphing y equals x squared, which is the parent function, and I already have here a table of values. That is the one that we are going to be using when we are transforming quadratic functions. So again, I'm evaluating x for y equals x squared. So when x is negative 2, y is going to be 4, because negative 2 times negative 2 is 4. When x is negative 1, y is going to be 1, because negative 1 times 1 is 1. When x is 0, then y is going to be 0. When x is 1, y is going to be 1. And when x is 2, y is going to be 4. Again, because 2 times 2 is 4. Now I'm going to go ahead and plot all these points here, and we're going to connect them so we can see how the graph looks like. So let's begin with negative 2, 4, 1, 2, 3, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. We connect them. And it is not perfect, but it gives you an idea of how the parabola looks like. Parabolas are symmetrical. The line that divides a parabola in half is called axis of symmetry. They also have a minimum or a maximum value. They have a minimum value when they are facing up, because this is the lowest value they will get. They cannot get any lower than this. They have a maximum value when they are upside down, like this. So then this will be the highest they will get. They will not get a higher value than this. This point is called the vertex. The y-coordinate of the vertex is the one that gives you the minimum or the maximum value. And the x-coordinate, that is the axis of symmetry. I think that's all I have to say about the actual graph. Go ahead and take a look at the next video. In the next video, we are going to be using the vertex form to transform this function or this graph.